Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome back to Geeks for Geeks. My name is Yash Dwivedi. I'm working as a mentor at Geeks for Geeks. I'm a candidate master on Code Forces, and a 5-star on CodeChef. Besides this, some other uh, uh, I have also some other achievements in CP. So today we'll be interviewing our guest, that is Tanmay. He is from IIT. So all of you can just quickly give me a +1 in the chat if my voice is clearly audible and everything seems to be working fine, so that we can invite our guest for today's mock interview. All of you can quickly give us a +1, guys, if my voice is clearly audible. Okay. So I'll invite Tanmay. Hi Tanmay, how are you?
Hi, hi. I'm fine. I'm totally fine.
So can you please quickly introduce yourself to the audience?
So, hello, people. I'm Tanmay Singh. I'm currently pursuing my BTech from IIT BSU. I'm in my fourth year. I've been doing CP from last 2 to 3 years. I've done quite a bit of web development also, two projects on that also, and I've explored a little bit of machine learning, but not to that extent. So
So
that's all from my side.
can you explain us about any of your projects that you have made?
So
Uh,
the first project which I did in my second year was basically one of my startup idea which I had with one of my colleagues. So the idea was to actually build a platform where doctors can actually make a centralized platform for their different appointment booking, because it's quite difficult. Like you go to a doctor or a clinic, and you had to book appointment. It's quite tedious. Like first of all, there's a lot of delay. You have to wait a lot of time. So our idea was to people can facilitate. There are other companies who are also doing that thing that Practo is also doing, but our idea was to we would build an algorithm which will actually find a particular period where that particular appointment is free for everyone, and so in that particular period you can book your appointment. So that was the whole thing which we try to build. uh, uh, in my second in third year the things doesn't go as planned, so we dropped that idea, but the website that I built for the whole thing was still there, so I used it as my project in my resume.
Great. So as you know, today I'll be interviewing and I'll be asking you at least two DSA questions in span of 45 minutes to 1 hour. So are you excited for this interview or you're
yeah
nervous?
yeah yeah I'm totally excited. No, I'm little with my
Okay.
one nervous also.
Okay. So can you share your screen quickly?
Okay. uh, Wait.
Down there, you will find a
Yeah,
screen sharing
got
option.
it.
Okay, so your screen is visible.
Is it
If you will look,
yeah,
yes, it is visible. If you look in the private chat, so I've shared a question link
yeah,
with you.
got
Can
it,
you quickly open that?
got it.
Okay, great. So you can quickly log in. Uh, Great. So let us start with the question. So the first question that I'm giving you, in this question, you have to count the total number of set bits. So what do you know,
Okay.
do you know what is a set bit?
Yeah. That number of ones, no?
Basically, if a bit,
Yeah,
either a bit can be 0 or 1. So if it is 1, then it is known as a set
one.
bit.
Yeah,
So
yeah.
what I'll be giving you is, I'll be giving you a number. Okay, that is n. I'll be giving you an integer number. And what you have to do is, you have to count the total number of set bits from 1 till that number n. Are you clear with this?
Okay,
If I give you, let's say 3, so in that case, you have to count the number of set bits in 1. You have to count the number of
mm-hmm.
set bits in 2. Then you have to count the number of set bits in 3, and overall you have to return the final total. So is the question clear to
Okay.
you? Because
Yeah.
if you
It's
will
totally
see,
clear.
so in 1 there is only one set bit, in 2 there is only one set bit, in 3 there is two set bits, because 3 is represented as 1 1. So total there will be
Okay,
how many set bits? Four set bits. So the answer
okay,
for n is equal to 3 will be 4. So what you have to do is, you have to tell me, like I'll be giving you the n value. and you have to tell me like how you will count the number of set bits from 1 to n.
Okay, so the first approach which comes to my mind is to actually iterate over 1 to n and count each and every set bits, like total do a bit mask thing and count all the set bits. You can iterate from 1 to n, and for each integer you can count it. So that's the first approach that comes to my mind. The iterate complexity is saying log of n. So to think that approach, that how we can do it in log n of n is an interesting thing. Uh,
Okay, so you can do one thing. You can remain on this screen only. There's no issue. But what I'm asking is like you are saying that what you will do is you will iterate for every number and you'll count the number of set bits in
mm,
that number. So
mhm.
that is very basic approach, and even the audience will
Yeah,
understand that. But
yeah.
one thing that I'm asking you is what will the time complexity of that approach? Can you tell us about that?
So basically, if I have to count that each every, so n log n would be the time complexity of it, because if each of number will be counted for log n, so and I have to iterate over n of them, so n log n should be the time complexity for that.
Correct. So can you think of
Yeah.
optimizing this approach?
So what can be the optimized approach for that? Mm, like if I'm taking a number n, so
Whatever you are thinking, you can keep on sharing your thoughts. Like you can think out loud so that we understand that
okay,
what is your thought process for the
okay,
question.
okay. So first of all, if I write number n, so can I do where I can do my rough work, like I can do it here also, or like.
You can do it here only. You can do it here only. No problem.
Okay. So what I can do is that if I represent
Uh,
n into
one thing you can do, you can click on the setting option and you can increase the font size a little bit.
okay.
Like right there. There's a setting option. You can click escape first of all.
Yeah,
There's a setting option. Yeah. You can increase
yeah.
the
So
font to
font.
let's say 16. 16 will be fine, I
Okay,
think. Great.
okay.
Now you can tell us.
So the first approach can be I should convert n into its binary form. Like if I say that n has some, let's say I take a number like let's say 3. So it's the binary representation of it will be one triple one, double one. So every number which is less than n will, like let's say 2 and let's say 1 will be less than 3. So what are the bits going to change? The first thing is that will bit will change, or the next bit, like let's say take a bigger number. I would say it's not that. So let's take a number like it is going to be let's say 16. Let's say 16 is our number. So the representation of it is like I think it's this. No.
Are you sure?
100. Yeah, 100. Sorry. So let's say 16. So every
I
number
think
which
you
is
need
going to
one more
be
zero for 16.
okay. Yeah. So every number which is less than 16 what will be the, like, first thing, if I remove the first bit of it, like 1, if I make it to 0, then all the numbers which are less than that I can find it. Like if I make the first bit is 0, let's say 15, then the representation of it will be 1 1 1. So if I remove the first bit of it, then other numbers which I can get will be the total count of it. Like, uh, so what we can do is that first we will find out what's the n binary representation of the largest number n. So what we can do is we can either flip this particular index or this particular index and this particular index. Okay, so once we do it, like if we flip this particular index and then this particular index and this particular index, so every time we'll flip each of the bit, then the and if I remove the first bit of it as set is at 0, then all of them will be less than n. So let's try to implement it
Okay.
first of all. Am I going in right direction, like
You
or there
can
is.
just tell us about a bit more. Like first of all, you are saying that you will have the binary representation. That is fine. I know that you can get the binary representation.
Yeah,
Then
and this
after getting the
the second thing, which binary representation, I'm saying that for each of the binary representation, each of the index of that particular binary representation of the number, I'm gonna flip each of its bit. So flipping its bit means that if the leftmost bit is 1, first of all we're gonna make that one 0, so that every number which we are going to flip in above that number is going to be less than n, because that's our priority, because n has to be less than and all the number we have to take is less should be less than n. Uh,
Ec-
so
But you have to count
after
for n
that,
as well.
and as well. So for that, we can do is, I think it's kind of a db plus bit mask thing. I what I can think of. Let's
Okay.
try to write a function of it for it. I think it's a db plus bit mask. Uh, but I don't think n login, the complexity is login.
If you had to do let's say something like DP only, then instead of that,
Login
counting
should,
for every number would have been better.
yeah,
Okay,
that's the whole thing because
so see, order of n log n approach is when you are iterating for every number, correct? But if we want a smaller complexity, so obviously the smaller complexity will be in terms of logarithmic only. So
yeah.
if you have to think log, so what does it mean by log? Log means that when you are basically iterating through the bits of a number, right? In with respect to this question, logarithmic complexity you will get only when you are thinking something about the bit representation. So
Yeah,
can you think a little bit more? You can be on the same screen. Yeah.
yeah. So what I can do in this is, for each of the n, I have to find the number of set bits. Like, okay, so first thing, yeah, let's take any number. So any number, let's say 16. So the last bit is going to differ after each of the one step. Like, if I take one, then it's going to one zero one one. So the last bit is going to iterate over. Let's say if I take 16. Let's say if I take 16. So
If you want, you can
for
take
one,
smaller numbers as well. If
one is going
okay,
to be
let's say
one,
you take
two
16.
is going to be 10, and three is going to be 1 1. So this last digit is going to be alternatingly changing it. Like first it's going to be one, then it's going to be zero, then it's going to be one. So for odd number of times it's going to be so the last number will be n by two, n by no
Okay.
on n by two plus one, and for like let's say four, four is four will for even number. For odd, the number of the last bit is going to be n by 2, and for even it's going to be n by 2. So this is the first observation I can see from this question. So if I take the second last bit, how it's going to change? Like if I take the second last bit, then uh,
Okay, let's do one
one
thing.
one,
Let's write it till four. Let's write it till four,
yeah,
and let's see what you can observe. And what you can do is you can write one as
1 0
zero
0.
one, so that we are more clear with it.
Yeah. Okay. So
Okay.
if I'm saying it to be the last bit is differing after each of time, and the second last bit is actually differing. Okay, okay. Let me see. Let me see. Okay, okay. What we can do is for each of the bit, we can find out how many times two is going to come. Like, uh, okay, let's say if our number is n, and I'm taking each of its bit low. So let's say it's going to be two, and this is going to be one, and it's going to be zero one, zero 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 one. Okay, so one is going to be. So this is two. Um, two has to be more than two times. Six. Zero. For seven is going to be one. So each of the terms, the number of let's if I take from how many times is going to flip.
Whatever you are thinking, you can think out loud so that we also understand what is your thought process.
Okay.
And Sanskar, you are saying that you are not clear with the question. So basically, what I'll be giving you is in this question, I'll be giving you a number n, and you have to count all the set bits from 1 to n. Like 1 has one set bit, then 2 will be having one set bit, then 3 will be having two set bits. So you have to count the total number of set bits from 1 to n. That is what you have to do in this
One two
question.
one zero one zero. Okay. So the number of sets, but so the number of two and zero is to be lesser. And mm, what I can for n by two, it has to be n by two, and for that, let's say for this 1 1. Uh, so for and I can do is, let's first take each of the bit, and each of the bit has is flipping for nth position after 1 times, and for, let's say, for the second position it's going to flip 0 1 1 0, and 7 for 8 is going to be 1 0 1 0 0. Okay, and for 9, okay, so it's going to flip like for 2 times. Okay, it's going to flip for, and similarly this position is flipping for, it's 0 0 0, and then for 4 times. And
So you're saying that for the third position, you're counting the number of set bits.
yeah, so if the for third time it's going to flip by, okay, so what it's actually, by seeing the pattern I can see that the last bit is flipping by 1, the second last bit is flipping by 2, and the third last bit is flipping by 4. So to look at the pattern, I think that uh, for the second last bit, the nth bit is flipping by 1, and
Okay.
n minus 1th,
So basically,
n minus 1th,
can you explain us a
it
little
is
bit more
flipping.
why you are saying this? What you are saying, I understand, but can you explain us a little bit more? You are saying that the last bit is
Mm.
flipping by 1. What do you mean by that?
What I mean by that is that if I take it from 1, so after 1 comes 2. So the last bit is going to be changes by 1, and then again it comes 3. So last bit again flip by 1. So each of the time it's alternatingly changing itself after one step. If I look at the n minus 2th bit, then after 2 step it's changing itself. Like for 1 it's going to be 0, but for 2 it's 1 1, and after that 4 and 5 it's again 1 1. And if we continue that pattern, I think that it will follow it. So for
So,
n minus n
so
minus
you're
2
saying that
bit, I can,
alternate basis, it is getting set and unset. You're saying this thing.
yeah, for n minus 2 bit it's getting changed by 4. So basically it's changing by to the power of to the power of what I can say, to the power of n minus 1. So n minus, it's actually changing with the to the power of n minus, since it's 1 bit, so n minus I, it's changing by to the power of I. So why it's changing, now that's a question. But for this question I can use this fact, I can use this fact to solve this question. So if it's changing by the 2, so after each of the bit I have to find that how many times it has come. Mhm. So for 4,
Okay.
and similarly we can do it for n minus 3. uh, okay, n minus 3 3th bit, we can do it for n minus 3th bit also. So it will change it by 8. Okay, so now what we can do is, if it's flipping, each of the letters flipping after, mm, yeah, so let's say if I'm at 1, and if it's at particularly 0, do you think that it's this particular observation is right? Like we can use this for solving this question, or there is some more observation which we can make
Uh,
for
I,
make out from this
what I
question?
can say, is I am impressed by the way that you are thinking, the pattern that in which you are thinking. It's almost, you are almost there, but you need to see. Like you are saying that, you are saying that the bits are flipping and all that stuff, right? You can again move
Hmm.
back to the coding screen only.
Yeah.
So what you are telling me is, you are telling me that how, what is the behavior of the flipping of the bits. But let's come back to
Hmm.
the question. What do you want? You want to count the number of set bits, correct? That
Yeah.
is what you want to count. So just keep this observation only. Maybe you can keep this observation, maybe, but just
Hmm.
think about every position, for every position, think about how
Hmm.
many set bits are there. Just think about that, and then tell me.
Okay.
There is an observation in this question. You have cracked the question correctly, that maybe there is some observation that I have to do. But what you need to think is, let's say that you are thinking about the last, like for every position, try to count the number of set bits there and then tell me. What is
Okay.
the number of set bits for the last position here? For n is equal to 8, what is the number of set bits?
For n is equals to 8.
Yeah,
Okay.
basically I'm saying that for n is equal to 8, what is the total number of set bits for the last position?
Okay. Okay.
You can quickly count it.
Okay.
Starting
So
from
1,
1
1,
till 8, what is the number of set bits for the last position?
1, 2, 4, 4, 1, 5, 5, 2, 7,
When I
7,
say last
9.
position, so basically I mean the rightmost bit,
Okay. 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 1, 2, 3,
because you were
4,
counting from there only, na?
4, 4, 4. Yeah. This observation I actually met that for the last position is if it's even, then it's going to be n by 2. If it's odd, then it's going to be n by 2 plus 1. Uh,
Okay, but let's count it for the second position as well.
Okay, okay, okay.
You
I
can quickly
think I
count it.
got this question. I think I got this question. So basically, what I have to do is for n minus
You can
two,
first of
we
all
can
tell us
say,
what you have observed.
yeah. So for
Yes.
second last position, we can say, for if I have to count, then 1, 1, 2, 2, 4. So it's going to be 4. So if I make an observation, then for this, if I this is for n minus 1 position. If this observation is for nth position, sorry. If this observation is for nth position, uh,
Basically the last position.
uh, the last position, we
You
can say.
cannot say nth
And
position because
for n
n is
minus
also
1
given, na?
position, we can say that uh, if it's odd, let's forget odd since it's even. So we'll look for even. Then for even, we can say that it's going to be n by 2 by looking at it. N by 4, sorry. N by 4. Uh, Now, if I look at the third position, then it's looking at 1, 1. Uh, what's going to be third position? It's 4. It's also 4.
Okay. So you are saying that for the second position also, that is from for the second position from
Yeah,
the right also, there are
right
four
also.
bits.
4
Okay.
bit. And that's 2th position. It's still 4 bit. If it's even, let's say for the case of even, it's still 4 bit. So if I actually look at this whole thing,
Why have you for n minus one, like for the okay, great. Why have you written n by 4 in the words section?
actually, I was thinking that it's following a pattern from for n it's going to be n by 2, n minus 1 is going to be n by 4, but I don't think it's following that pattern. It's it's 4 bit, 4 bit.
Okay. Can you
Okay.
tell me for the third position from the right, how many bits are set?
For the third position, it's 4 bit bits are set. I think
Correct.
four,
Correct.
yeah, 4 bits are set.
So again, 4
So
bits are set.
mhm.
So with respect to the value of n, what is 4?
So obviously 4 is n by 2, n
N
by
by 2.
4,
Okay.
n by 2,
Okay.
n
And
by 2.
if I see, so there are total 4 positions I can see, right? Because there is,
Yeah.
since there is 8 also, so there is one more additional position, that is the fourth position that I can see. That is the leftmost position.
Mhm.
And can I say
Left
that the
position.
leftmost position in everybody is 0 except for 8? Correct?
Except for 8. Yeah. Yeah.
So maybe I can take it as an exception and I can maybe handle it.
Yeah. Yeah.
Okay. But does this like maybe you can see a pattern, right?
Yeah. Yeah.
Okay. But does it prevail for all the numbers? That is the thing that you have to choose.
Okay. For 1, if it's going to be, um, and for 4, if I'm asking for the fourth bit, then it's actually changing for 4, and for that 4, it's changing for. Hmm. How many times it's changing? Let's say if I take this bit.
Let's say you take it for n is equal to 6. So does this pattern prevail?
No, that's only I'm saying that it doesn't work for that. But why? What I'm thinking of a different approach for this question. Uh, what I can say is that for 1, it's going to be 1. And for 6, we have to look at the number of times it. So what we can do is, if for the second bit we are having And for the fourth, we can see that, okay, observation I can think of now is this is 4, and okay, let's look at it. What I can think of now is like if let's say there are if I'm at third position, it's let's say 100. So the number of bits it can flip on is 1 and 1. Like let's say what can be possible 0 and 1. So 2 into 2 4. So the 4 times it can. There are 4 combinations that are possible for this particular thing. Like it, and the number of count is going to be. Hmm, okay, what I can think of is that for each of the to the power of x position, we can find out the number because I think that's a following a particular thing, and we can think that what's nearest to the n and what nearest to the power is n. Uh, let's say
Okay.
if I have to find for if let's say we have to
Why
find for
are
4.
you okay? Why are you finding nearest
Let's
power of 2 for a given value of n?
because I think that if we are able to find that the nearest to the power of 4, nearest to the power of 2, then there are for the nearest to the power of 2, we can find out. And if we are able to find the pattern for the nearest to the power of 2, then we can use same pattern to find for n. So let's say for
Okay.
first we look for each number which is the power of 2. So let's say for 2 we are counting the number of set bits. So if we are counting the number of set bits for 2, then it's for 2 is going to be 2. The total sum of the set bits, the number which are less than 2. For 4, we can say that let's write here 3, 0, 1, 1. For 4, we can say 1, 0, 0. For 5, we can say 1, 0, 1. 6, we can say 1, 0. Sorry, 1, 0, 0. Uh, for 7, I can say 1, 1. And for 8, I can say it's going to be 1, 0, 1. So first we will find for 2. So for 2, it's the number of count of it is for 2. For 2, it's 2. For 4, it's 1, 2, this 2, 2, and 5. For it's 5. For 8, the total count of set bits are 1, 2, 4, 4, 3, 4, 3, 7, 7, 7, 2, 9, 9, 9 plus 3, 12, 12, and 13. Okay, so if I look at the pattern for this, the total count of it is hmm,
Initially, you were thinking in the right direction. Now there is a little bit of problem with your thought process.
I think that's not working. So for that particular process was I am I was making 1, 0, 0, and it's alternatingly changing for 2. For for the second bit, it was changing for let's say it was 2, and after 2 position, it was changing. For this, it was let's try to find out for a little bit more. 1, 0, 0, 1. Then it was 1, 0, 0, 1, 1, 0. So I think that pattern holds because like it alters after 2.
Okay, so for n is equal to 10 for the rightmost bit, how many bits has it?
For the right mode split, 1, 2, 3, 4, 5, 5, 5 are set.
Okay, so that's n by 2 you are saying.
Yeah. That
For
holds.
second
I think
position
that's cool.
from the right side, how many?
For okay, wait a minute.
Okay, for
Wait a
the
minute.
second position.
I think the question answer would be 4. For the if I looking at the n minus 1th position you're asking for, so 1 1 4
That basically you should not say n minus 1. You
5.
should say the second bit from the
Yes,
right.
the second last bit. Okay, so for this last bit is it's 1. Last bit it's 1. It's 5. And for the second last bit I can say, if I'm not the second last bit, then 2 to 4 and 5. Actually it's okay. Uh, and if you look at
Okay,
this third last bit,
third
then it's
last.
going to be 4 4 uh, 4 3 7. Third last bit is going to be 7.
Are you sure?
Wait a minute. Third last bit. Okay, sorry, 7, not 7s. Uh,
If 7 bits will be there, like I don't think
6
they
6
will
6.
do
Sorry,
that.
sorry. Yeah. Sorry. So third last bit is going to be,
I think
it's
let's
going to
see.
be 2 3 4. It's going
Look
to
at
be
the
4.
third last one.
It's
Yeah,
going to be
it will not be more, no? It
4.
will not increase.
Yeah, it will not increase. Okay, so it's 4.
So the pattern does not exist.
Yeah, the pattern does not exist. Uh,
But the pattern exists till 8.
yeah,
And the unique thing about 8 is a power of 2.
yeah. That's what I was thinking, that we need to think for the to the nearest of the to the power of, and then we
Okay,
can.
let's say the pattern exists. So for which kind of numbers does the pattern exist? If you are able to see that the pattern is existing.
Then it's
So
existing
for
for to
which
the which are
Mhm.
power of 2. The numbers which are power of
Okay,
2.
okay. So it is existing for the power of 2.
2.
So if I give you n is equal to 10, let's say. So
Hmm.
can I uh, can I expect like let's say if I give you n is equal to 8, that is a power of 2 only. So what will how will you count the number of set bits if the pattern is existing? Then what will be your approach or formula or something based on this pattern? At least for a power of 2, what will be your formula?
So for the power of 2, if I have to just find the for the power of 2, then what's going to be the formula? So
Yeah.
the first thing which we can observe for the power of 2 is, so what was the total bit of number was for 8? I think I think if it was holding like, it was 4, and then it was 4, and then the third set bit was 4. So it was total, uh, 4 was 3 times, so, and 1 was extra. 4 into 3 plus 1 was the pattern, because last bit and the second last and third last was 4 4, and the fourth bit was 1 here. If we see for this also, then it's for first for 2, then again it was 2, and then 1 was getting added at the last. So for 4 the pattern was for 2 into
Uh,
2 plus 1. Okay.
no, no. Just tell me in terms of numbers now. Like in terms of value, in terms of n, what will the formula? If you are able to observe this.
If in terms of n, what's going to be the formula? So for in terms of n, if I have to find the formula, then for 8 it was, for let's say 8. So for 8 it was 8 by 2, and that was accounting for n minus 1. So I think the formula for to the power 4 is going to be
To
n by 2 if it's obviously it's going to be even, and into n minus 1 plus 1. I think that's going to be the formula. 4 into, no,
you should
sorry,
not
sorry,
say n
not n
minus 1,
minus,
na?
n by 2 minus 1. I think n by 2 minus
No, no,
1.
basically the power of 2.
Power of 2. Yeah. So let's say n is the power of 2.
Yeah,
Power of
so
2.
whatever you can say p, Because
we can see P.
for 8, you have 3 positions in which you are having the same pattern. No?
Yeah. So for to the power of 2, we can say that it's going to be P by 2.
You should write it as n by 2 into this thing.
Okay, I should write it n by 2. Okay.
Yeah, n by 2 into p.
N by 2 into P. Okay.
Yeah, because the power of whatever power of 2 is there,
Yeah, got it.
you should
Yeah, sorry. P minus 1. To the power 3. Okay.
into
To the power 3 is,
p. No?
it's going to be, yeah, okay.
Okay, so maybe you are whatever extra bits are there, you can count it. Correct. But
Yeah.
now, just do one thing. Have that 9 and 10. Just put that 9 and 10 close to 8 only. And now let's try and observe for the further cases.
Okay.
Just put that 9 and 10 now. Okay. So for the power of 2, you are able to calculate. Okay.
Yeah.
Now there is 9 and 10 also. So how? Okay.
Yeah.
So till where you have counted? Let's say you just count for, let's say there is a rightmost bit that is 1. In 8, 9 and 10 there is a rightmost bit that is 1. Correct.
Yeah.
So maybe you will handle. Let's say you handle it later on somehow or the other, or maybe through some pattern you'll handle it. But till where you have counted the bits? Can I say that you have counted it till 8? Till 8, all
Yeah.
the bits are counted except the last set, the leftmost bit. You have counted all the things, right?
Yeah.
Then if you observe, so 9 and 10 is there. One bit for one. See, the leftmost bit in 8, 9 and 10 is what you have not counted.
Yeah.
So that maybe you will handle it somehow. Maybe you will handle it somehow. We don't know as of now. But if you will see, so now which numbers are there which do have like, if you ignore the leftmost bit, that is 1 in 8, 9 and 10. Other than this, which bits are not counted?
Okay. Okay, but one thing is that if we are going to the closest to the power of n, so the complexity is log of n. So for other, we can just count it like iteratively, like we can do brute force for that. It's going to affect our complexity because.
Okay. Okay, you write 11 as well. Let's write 11 as well so that we can observe something more.
Yeah. Let's write 11. 1 0.
1 1.
Yeah.
Okay.
1 12.
Now just I did till 11 only. We can see till 11 only. Now just do one thing. Just put them into place. Yeah, 8, 9, 10 and 11. Just put them in one line so that we can observe something. Just put 8 also with a space. Okay. So if you see till 8 you have counted. Let's say you have not counted the rightmost bit. Okay.
Yeah.
Let's say you have not counted the rightmost bit. So how can you count the rightmost bit here? Any idea?
For the right mode, it's going to be easy because it's if any of the number, like
How many?
the nearest power.
Sorry, how many leftmost bits are, like, basically not rightmost, leftmost? So how many leftmost bits are not counted?
For what?
For n is equal to 11, some leftmost bits are only not counted.
Yeah.
Yeah.
So for the leftmost bit, what we can see is.
If you'll observe, what is like, basically, if you will see four bits are there now. For 8,
Yeah.
1 bit is there, 9, 10, 11, 12. Okay. What is the closest power of 2?
Closest power for 11 is going to be 8.
So is there some relation between n and the closest power of 2 that you can do so that you can find it?
Okay.
N minus the closest power of 2 plus 1, no?
N minus
8.
Power of, yeah.
N minus 8 plus 1. What is n minus 8 plus 1?
8 plus 1 is going to be 11 minus 8 is going to be 3, and 3 plus 4.
So 4 bits, you can count the extra bits. Okay.
Yeah.
Let's say you have also counted the extra bits. Now which bits are not counted? So from 9, 10, 11, if you will observe, so which bits are not counted? 0. See, in 9, 0, 0, 1 is not counted. Correct. You have not considered 0, 0, 1 till. For 10, you have not considered 0, 1, 0. For 11, you have not considered 0, 1, 1.
0, 1, 1. Yeah.
So if you separately think it, can I say that 0, 0, 1 is nothing but 1? Can I say that 0, 1, 0 is nothing but 2? Can I say that 0, 1, 1 in 11, the 0, 1, 1 portion is nothing but what?
3. Okay.
3.
I
So
see that.
again, the question boils down to counting, like,
So
okay,
that
what is 3 here? What is 3? N value is 11. What is the closest power of 2? 8. So what is 3?
8. 3 is basically 11 minus 8. Okay, got it. So for 12 is going to be,
So again, what you will do is, again, you will count for n minus the closest power of 2. Are you getting this?
yeah, yeah, got it.
But
Again, for 8
you could
minus.
have, like, basically what you will do is now, you will first of all find the whatever value of n is given, you will find the closest power of 2 for that, and then you can count the bits, okay, for the closest power of 2. Then the leftmost bits that are there, you can also count them. Then what is left is some bits from here. If I see till 8, everything is counted, and the extra bits in the left side for every number is counted till n. Now only the bits that are there that are left, 001 is left, 010 in 9, 10, 11, 12 respectively, all these bits are left. And if you will see, so that is nothing but n minus the closest power of 2, because if you give me 12, so
So, okay,
from
okay, okay.
9 till 12 I have to count the number of bits from 1 to 4. That is nothing but from 1 to 4 now. So
Yeah,
again, you have to recursively call the function.
yeah.
So
We
all
just gonna take the difference, and then again we will find, we just gonna take the difference to the nearest power of 2, and whatever the answer we will get, will again find the nearest power of 2, and then we're gonna take the difference and find it till we got to the last point. I got it.
but one thing I'll say, you were able to come up to this thing very, very soon. You set closest power of 2 very, very soon, but maybe
Yeah,
somehow you lost in between because you were thinking about some permutation combination or something.
yeah, yeah,
Maybe you were
yeah.
thinking a little bit more mathematically, but if you would have just kept given it a little bit more thought, maybe you would have cracked it. But no worries. Let's move to another question. So I'll quickly move to another question. So what I'll do here is, if you will look at the private chat, so I have shared a document with you. Can you open that?
Yeah.
Okay. So let's quickly see this question as well. Okay. So let's quickly
Okay.
read the question. You know about binary trees?
Yeah.
Uh, Basically left child and right child. Every root
Yeah. Yeah.
has
Yeah.
two children
Got
maximum,
it.
right? Left and right.
Yeah.
So what I'll be giving you is, you can do one thing. You can click on like you can click on full screen if it is possible for you. I think it's F11 or something.
Go. Is it like?
Great.
Okay.
Great. Yeah, works fine. Okay, so just scroll down a little bit so that I can show the problem statement to others as well. No? You can
Okay.
scroll down, like, yeah, right. Perfect. So see, I'll be giving you a binary tree, and what you have to do
Mm-hmm.
is, in this particular given binary tree, you have to split the given binary tree into two different subtrees. Okay, you have to
Okay.
split it. Maybe from the diagram you can see, like, there's a particular binary tree given, and there is a colored edge. So basically, from that
Okay.
edge, I'm splitting the binary tree into two different halves. Okay, so I don't
Okay.
know from where I'll be splitting. I don't know, but there's some at some point of time I'll split. Okay, so there's one edge that I'll remove, so I'll get the binary tree in two different components, correct? Basically two
Okay.
different parts. It will split into two different parts. And what
Mm-hmm.
my task is to split the given binary tree into two different parts, right? By removing one of the edges. Basically we'll remove one edge, then it will split into two different parts. So I have to split it into two different parts such that the product of the sum of the subtrees is maximum. Because if you'll see, if I split it from this orange edge, then the first part is what? 2, 4, and 5. The sum of that particular part is 11. And the second part that I see is 1, 3, and 6. Sum of that part is 10. So if I multiply that
Mm-hmm.
part, so I'm getting 110, which is the maximum product that I can get. So basically what you need to do is, you need to find the maximum cost of splitting a binary tree in which you can remove one edge and you can get the maximum cost. Are you clear with the problem statement as well?
Yeah. Yeah. I'm clear with that. I'm clear with
If you will try to split it from any other edge, then you will not get the maximum answer. You can try that out as well. Can you move to the
Yeah.
second example as well so that I can explain to you as well? We can have a look at that. Okay, so now
Yeah.
if you see, again a binary tree is given. Now you can try to split it from various ways, but the orange edge that is given from there, if you'll split, so you'll get the maximum answer. Because if you split it from there, then the first component has the sum as 6, the second component has the sum of the nodes as 15, so the product will be 90. And you can try your combinations, you will not get any product better than this. So what
Okay.
comes to, like, is the I hope that the problem is very much clear to you. So what
Yeah.
intuition
Yeah.
comes to
Got
your
it.
mind?
So first intention that's coming to my mind is that first of all I'm going to calculate what's going to be the subtree for left and right. What's going to be the sum of the subtree for the left and subtree for the right, which we're gonna store in 1 and 0 form. Like for right is going to be 1, and for 0 it's going. So for each node we're gonna pre-compute it for what's going is the sum of left subtree and what's going to be the sum of right subtree. Uh, so
Okay.
what we will do is first we're gonna do a DFS search, and from the root we're gonna first go to the left subtree. Since we already know what's if we go to the left subtree, we will take the sum of the right subtree of that node from where we are going to the left subtree, and the parent of it, the sum of the parent of it, we will also store it, so that we are basically we are rerouting the node. Okay, are you getting me? On which node we are going,
Okay.
we are rerouting that node at that particular point. Are you getting
Okay.
my point?
So
Like,
you are saying that you will
let's say
for every you can
I'll
continue.
do a dry run. I'll do a dry run on example one. Okay. So for let's say I go for one. For left subtree, I'm going to store the sum for the left subtree, that is 2 plus 4 plus 5, and for right subtree I will store for 3 plus 6, which is 9 for one. Similarly
Okay,
for
so
two I will
first
store
of all,
4.
before you move forward,
Mhm,
you are saying that you
mhm,
will do this thing. Okay, so it will not add up
mhm.
and automatically. You have to do this thing. So what kind of traversal will you apply for it?
For that I can see that
Is there
in order
any specific name for the traversal that you are applying? Because
I think for if I'm applying, then I'm applying I'm applying for like in order traversal, like because I'm first
just think
visiting the
about it.
left node. First I'm visiting the left node, then I'm visiting the right node. Or I can do the reverse of it, like for the right node also we can visit, for then log in the left node. So it's not in order traversal. The post order and pre-order traversal, it can be both of them, and both will work fine, I think.
Post order,
You know,
basically post order.
yeah, post order. Okay.
Uh, Either
Hmm.
you can do left, right, or root, or you can do right, left, or root. But basically,
Right,
that's
left node.
nothing but post order kind of thing. Okay, then
Post order. Okay. So basically, we'll do this also. So we'll store the left for part of it and right part of it. Similarly, we will do for one. Similarly, we will do for three. So once we have pre-computed all the left subtree of a particular node and the right subtree of sum of left subtree of a particular node and right subtree of a particular node. So then again we will do a second traversal in which we have computed all the left subtree and the right subtree sum. Uh, then what we will do, if we are going from 1 to 3, so what I need from 1, if let's say not, it's not a great example, let's say I'm at 2.
uh,
So what I need from 2, if I'm traversing to the left of it, then I need the sum of right part of it, this part of it, and the parent that it had already as sum of it. And 4 already contains the left and right of it, so we're gonna sum and find. So for each of the time we're gonna break this edge, and we're gonna do a product of it. So I should implement it, like it's a little better if I implement it, like
you can
if you
quickly write
need.
the code. So you can assume that I'll be giving you a function. You will be
Yeah,
doing
so
this thing
is it
on the
right,
doc only.
okay, okay.
Yes,
Is it a right approach? No, I think this is only we have to do.
you are
Or
almost
there,
there.
yeah,
You are almost thinking in the right direction.
yeah.
But can you tell us a little bit more in this example how you will identify this orange edge, or how you will break it from here? Like see,
uh,
you will always keep a track of the maximum, but how will you get this particular sum as 1 1, like multiplication as 1 1 0? How will you get that?
so for 2 already I know that what's going it had the sum in the left and the right subtree. So we're just gonna sum for it, because we know that if we are breaking the edge, we are breaking the parent of it.
Okay, so you're
We are
breaking it
breaking the
from the
edge
current root.
current root. So obviously the edge which is being broken, I know the we have already pre-computed for one all the right subtree, and we are saving that particular thing in our DFS function. So we know that product, and we're just going to multiply the sum of the left and subtree and right subtree for the two, and we want to find for each and every node we will for each and every edge we will visit.
But there is still one conflict, na? Like for one, you are not multiplying the left subtree product and the right subtree product. You are considering the root in the right path that you are breaking, na?
Okay, what you're saying,
I am
if
saying that you are saying that maybe you are breaking it somewhere from one, correct? You are saying this thing
yeah.
that you are breaking it from one. That is your current root is
Mhm.
one. Then maybe you are breaking it. So you are saying that
No, no,
you are multiplying the
my
left.
what I'm doing is I'm not breaking the edge from 1 to 2. If I'm at 2, then I'm breaking the edge for the parent of it.
Okay.
So
Okay.
already
Okay.
we have stored for the parent. So we know the value what we have already pre-computed for the parent. So if we are on node 2, then we are breaking the node from the edge from 2 to 1. So we already have that particular parent. The let me
Okay.
implement it. Like it will be better if I implement it. It will be much more clear.
I'm clear with it, but I just wanted some clarity on the dry run. So what you can do is now you can just think of a function in which you will be given, you will be
Okay.
returning an integer
So
value, and you'll be given
I
the
should
node.
write it. I should
Yes,
write it
yes, you
here
can write
only.
it.
Okay.
Yes, you can write it here.
Okay. So let's say I'm
You have to
first.
return the integer value, and you will be given the root of the tree.
First, I'm gonna
In
pre-compute all the things. Like if I say, then I can do it for, let's say, an integer is n, the number of
so you are going
nodes.
to apply DP here.
No, not BP. I just pre-compute it, so I can do it pre also. Generally use for as a DP. So and 2. So 2 represent the left, 0 represent the left node, and 1 represent the right node.
Okay, so let's say I put one more constraint on you.
Yeah.
Let's say maybe you can do okay, let's say that you can do this using taking by taking some extra space here, right? That is
Okay.
using this pre-computation, you can do it. But if I
Okay.
put an additional constraint on you, that you cannot do it using
Mm-hmm.
this particular extra 2D array, 2D matrix that you are taking, then anything that you can think
Okay.
of?
Okay. So in
Let's say
that
if I
case, what
ask
I
you that
can.
you have to do it using the traversal only, somehow or the other, using some traversal only
Okay.
you have to do.
Okay. I got it. Got it. So if I have to do it using
And I
traversal
know that
only,
you can do it.
uh, so what I'm gonna do is first I'm gonna find for each left I will know the number of I will find. Okay, let me find for it. I'll write the code for it. It will be better. Int answer, and let's say
So
3.
if the audience is clear with the question, so guys, you can make sure to hit the like button and please comment on a +1. Okay, because the questions today asked were of good level. So you can just quickly write a +1 in the chat.
So root. So what I'm gonna do is first of all I'm gonna find the sum for the left of it. Let's say if I find the sum for all the left subtree. Uh, Once I have the left subtree, I know that this is the whole sum. Now we are going to iterate over the right of it. So now we have the parent and we have the total what I can say, the total sum for it. Mm, Wait a minute.
Subtree sum.
This subtree sum. Okay. I'm going to then traverse for this edge, and if I break this edge, okay, so I have the sum for it, um, and then I can traverse on it, and then if I traverse on it, then again I'm going to fight. So I'm going to break each of them. Okay, let me break. So yeah, what we am going to do is let's say int answer is my first, and the, uh, it's let's say it contains the total sum of it. So if I have the sum of it, then first I'm going to traverse for what I'm going to do. First I will traverse for left, then I'm going to for right. Then I can say that sum is going to be sum is equal to sum plus uh, root
Data.
root, root val. Okay, and then I'm going to pass that root to again answer. Then we're going to just traverse to the left part of it. It will work for if we don't do the pre-computation, then we have to break it.
Uh, just the thing is that you have a lot like in the first question also you were saying that you will do DP bit mask, and the second question also you are saying that you will do some pre-computation, but you need to just keep your mind away from those things and just think how you will traverse and have the access. So see, first thing is that you can I
So
say that you can have
okay,
the
okay,
sum of the whole tree.
okay. Yeah, that's the point. First, we will find the sum of the whole tree, and then for each node, we're gonna find for the left and right, and we're gonna sum it, and then we will subtract from this whole sum we have, and then we're gonna take the product of it. So that's the whole
Correct.
thing I'm gonna do. Yeah, that's
Correct.
the thing.
That is what you will do. See, you will find the sum, and then from whatever current node you are at, you will try to break from it. So you know the left sum of it, you also know the right sum of it, you know its
I,
data.
I was
So
I was overplaying it.
yes,
Yeah,
like there was no use of
yeah,
like using that to the array and all
yeah,
those things,
yeah,
right?
yeah.
It would.
That I got it. Got it. It can be done
So
easily.
audience is clear with it. Basically, what he will do, what he's saying is, he's saying that you can move to the first example now. Okay, so
Yeah.
what he's saying is, he's saying that when he will be at 2, so he will like whatever, like he will do a post order traversal. Okay, because post order traversal helps us to optimize in order of n time. Because if we know the left data, we know the right data, then we can do the calculations for the root. So for every current node that he is at, he's trying to break it. So when he is at 2, then he's saying that for the left part of it, he will calculate the sum. First of all, he'll call in the left, so he'll calculate the left sum, he'll calculate the right sum, then the current root is also there. Suppose he has already calculated the whole sum of the tree by doing one traversal or something. So what he's saying now is, he's saying that now he knows that what is the current subtree sum rooted at a particular current root, because he knows the left, he knows the right. So if he adds the current root data to it, then he'll get the whole subtree sum. Let's say he knows that in for 2 in its left it is 4, for 2 in its right is it is 5. You can move back to the doc.
Yeah. Sorry. Sorry.
Okay, then what will happen after this? Basically, he's saying that he will have the sum. So sum will be what, 2 plus 4 plus 5. That sum he will get, and rest of the sum how he'll get. So he was thinking to use some extra data like array or 2D matrix for it, but you can do it by calculating the sum. If you already know the sum, then you do sum minus the all this data, that the root data plus the left value plus the right value. Then you will get the other sum, and every time you can keep on taking the product, and whichever product is the maximum, in that case you can return it. Correct? That is what you're saying.
Yeah. Yeah. Yeah.
Okay, so now you can stop sharing your screen, Tanmay. So
Yeah.
let's come to the part. So after this mock interview, like what do you think? Did you improve, or did you learn something from this mock interview given the questions and the level?
The first important thing I learned was to actually do the question and to do in front of somebody is quite a difficult thing. I generally used to do a question, but I don't try to explain it to somebody. So that's my first experience on explaining to somebody while doing my question, and that's a tough part because to do also and to explain, you need to maintain a communication also, and you have to work on your brain also, and you have to
Think.
think the problem also. So that's the toughest stuff. You need to practice that. I didn't practice a lot at all for that. So yeah, I was fumbling a little bit in the middle of the whole interview. So that's the other thing that I need to improve on and to look upon it.
Okay. And I hope that you like the quality of the questions that we took.
The
Okay,
question,
like the
first question was pretty good question. I think the first time I saw it, I thought that it can be done it can be done using DB plus bitmask, but it was a greedy one. It was a good greedy one. It was a great greedy one question.
it was observation based question. It was asked. The first question
Yeah.
was asked in Amazon. Second one was
Mhm.
asked in Microsoft and Adobe. Okay.
Okay. Okay. So
Now
Amazon
coming to the
interview.
like, yes, the first question was from Amazon.
Okay. Okay.
Second
Got it.
was second one was from Microsoft and Adobe. Second one was easy. That is why I kept it in the end, because I knew that you will be able to solve it. Now, like,
First
but you have a lot of DP in mind every time, so you can improve on that one. Don't think every question has DP. Okay. Now another thing. Do you want a feedback from me?
Yeah, yeah,
A
sure,
little
sure.
bit
I
feedback.
want to
Okay.
figure.
So see,
Mm-hmm.
what I observed was that you were thinking in the right direction. Maybe sometimes you were just talking to yourself. So don't do this. Like as you said, like it's difficult. So whatever you were
Mm-hmm.
thinking, just try it. Whatever you are thinking, whatever you are thinking in your mind, just put that. Like just think out loud,
Mm-hmm.
nothing else.
Mm-hmm.
And apart from
Mm-hmm.
this, I know that your thinking capacity is good. You were thinking DP but plus bitmask. Maybe sometimes you were overthinking. So don't do that as
Yeah.
well.
Mm-hmm.
Try to decompose. Like if see, if you are going for a very big company, let's say media.net or coordination or something, then
Mm-hmm.
that thought process is good. But if you are going,
Mm-hmm.
let's say, for normal interviews only, then don't
Mm-hmm.
overkill, don't overthink the question,
Yeah.
don't do bit mask, and don't think too much.
Mm-hmm.
But that was great.
Yeah.
But you observe the pattern in the first question that I like. In the second question also, you were thinking good, but as I put a constraint on you that you don't have to use the 2D metrics, then you were a
Mm-hmm.
little bit uncomfortable, but immediately you got to know that okay, you can find the sum. So overall, it was a good interview, and I hope that others also liked it. It was a little bit on the harder side, a little bit, no, not much, but it was like the first question was obviously it is not very easy when you get it for the first time. So Tanmay was still able to do it. So thank you, Tanmay, for giving us your time and
Thank you. Thank you.
volunteering for this mock interview. And I wish you all the best for the placement
Thank
season.
you. Thank you, sir. Thank you.
Thank you, Tanmay.
Thank you.
So that was it for today, everyone. I hope that you like the level of this mock interview. Make sure to register for the mock interview. You can find the link for it in the description of this video. The Google Doc will be like the Google form will be present, and you can fill it if you want to give the mock interviews with us. And another thing is, make sure to like it if you found that this video was helpful. Uh, Thanks a lot, everyone, for joining, and I'll see you in another mock interview. Until then, it's goodbye and take care, everyone. And make sure to hit the like button as well if you liked it. Bye, everyone. So it happens every week. It happens 2 days, Samrat. So thank you, everyone, and bye. Take care.